today, day 3 of section 8.3. We are going to be wrapping up confidence intervals for means, and the main focus for today is learning some more calculator shortcuts in order to help us do the computation here. Okay, going to dive right into an example. This is from your textbook. Several years ago, the U.S. Agency for International Development provided 238,300 metric tons of corn-soy blend for emergency relief in countries throughout the world. CSB is a highly nutritious, low-cost fortified food. As part of the study to evaluate appropriate vitamin C levels in a food, measurements were taken on samples of CSB produced in a factory. The following data are the amount of vitamins of the following data are the amounts of vitamin C measured in milligrams per 100 grams of blend for a random sample of size 8 from one production run. Construct a 95% confidence interval for the mean amount of vitamin C, mu, in the CSB from this production run. Okay, so some things right away before we even dive into this problem. If we're talking about a confidence interval for means, and you don't know population standard deviation, which we typically do not for this particular class, then it's going to be a T interval. Now, if we're going to make a T interval, if we know our population distribution is approximately normal, sample size does not matter. If we do not know population distribution and our sample size is greater than 30, we're good. Okay, we don't know population distribution and we have a sample size less than 30. So this is the trickiest of the different versions we've done. We're going to have to examine sample data in order to meet our conditions. Okay, so those are the kind of the red flags, things you should be thinking of right in the very beginning of the problem when you first read this. Okay, now on to the 4-step process. We wish to estimate mu, the true mean amount of vitamin C in the CSB from this production run at the 95% confidence interval. Okay, detail here, we're only sampling from one production run, so that means we can only make a statement about that one production run. You can't extrapolate beyond what you sampled from. Okay, how are we going to accomplish that? We're going to construct a one-sample T interval for mu if the conditions are met. Okay, the random condition. It specifically says in the problem the data comes from a random sample of CSB. We must assume the sample size of 8 is less than 10% of the CSB from this run. Okay, large normal sample. We do not know the shape of the population distribution, and we have a small sample size of 8, which is less than 30. We must examine the sample status. So before we even read any further, what we want to do is look to see, do we have strong skewness, do we have outliers? No strong skewness, no outliers, then we do not have reason to doubt the normality of the population. So here, it's showing the box plot. As shown in the box plot, there are no outliers or extreme skewness. We do not have reason to doubt the normality of the population. Okay, we're not making a final statement about this sample. We don't care if this sample is normal. It's does this give us reason to doubt the normality of the population? Okay, outliers with a box plot, that's cut and dry. There are not outliers. There's no opinion. Okay, what distinguishes slight skewness from extreme skewness, that perhaps is gray. If you have the feeling that maybe there's more skewness there than you think there should be, you always make the assumption to continue with the problem. Don't say there's extreme skewness, take your calculator and go home. Okay, make note of this skewness perhaps could be classified as extreme. We will proceed with caution. Okay, that's a generic, safe way to go of making the assumption to continue with the problem. Proceed with caution, noting whatever the anomaly is for the problem. All right, so we know that we're going to have to make some kind of graph for this. And we know we can make a box plot pretty quickly in our calculator. They also don't give us any summary statistics. We don't know sample mean, we don't know sample standard deviation. So even if we were to approach this problem the exact same way we did one of the examples from yesterday where we had the raw data, we're still going to have to get this in our calculator no matter what. Now, as long as we're getting it in the calculator, I'm going to show you some other things that make this problem a little bit more manageable. All right, so let me turn off that stat plot. Go to stat edit, get rid of that data from my calculator, still left over from yesterday. Put in the new data, 26, 31, 23, 22, 11, 22, 14, 31. Going to turn that stat plot back on, zoom 9 it, and there's the box plot that got copied there. All right, so we definitely do not have outliers. That's black and white. And as long as we can get away with this not being extreme skewness, that condition gets met. All right, here's what we can do to bypass some of those calculations, or many of those calculations we did in yesterday's examples. If we go to stat tests, we did, which one did we do in section 8.2? We did the one prop Z interval, the one proportion Z interval. What we want to do here is a T interval. Okay, now we can work off of this two different ways. We can work off of summary statistics. If they told us the sample mean, sample standard deviation, sample size, confidence level, type all that stuff in and get calculated. Or working off of the raw data. The raw data is an L1. We're not working off of frequency lists here. Our confidence level, what was it for this problem? 95. Calculate. It tells us sample mean, tells us sample standard deviation, tells us our sample size, and gives us the interval. So what is required for full credit in order to use this feature of your calculator? Okay, by AP rubric, if you're going to be using your calculator to do a problem like this, see everything, no glare. Okay, that'll work. Is state using technology, anything T related, you always want to be specific with your degrees of freedom. So if our sample size was 8, our degree of freedom was 7. The confidence interval is. Okay, as long as you state your degrees of freedom, state that you use technology, have the correct numbers there, then that would be considered full credit for the work. Okay, for the interpretation, we are 95% confident that the interval from blah, blah, to blah, blah, make sure you have your label, captures the true mean amount of vitamin C in this production run. Make sure it's context to the problem. Make sure you're being specific in terms of what you sampled from. All right. Word of note here on the bottom. Similar to something we've said multiple times throughout the whole class. You may use your calculator to compute a confidence interval in the AP exam, but there's a risk involved. If you just give the calculator answer with no work, you'll either get full credit for the do step if the interval is correct, or no credit if it's wrong. The extra thing that's there is they very also want the degrees of freedom. Some rubrics require it, some don't. If you're going to use your calculator to construct the interval, do not show the formula. You'll run the risk of parallel solutions. If the formula and the calculator produce different solutions, choose one strategy or the other. Another option, do both, cross out the solution you don't want. You have an ample amount of time on the AP exam to complete the free response questions. If you were to see a question like this, you might want to do it two different ways. Do it once by hand, do it once by the calculator, make sure they're similar. They're not necessarily going to be exact. If they're significantly different, you know something's wrong somewhere. And then once you decide which one you want them to grade and which one you don't, cross out the one that you don't. Okay, chances are you're going to want to stick to what the calculator told you and cross out the scrap work that you would do by hand to check that work. All right, so what is provided for you on the AP exam in terms of reference? We've seen snippets of this in different spots of the PowerPoints. Okay, relevant to what we're doing in this chapter, they give you the blank structure for a confidence interval. All confidence intervals are going to be some sample statistic, a critical value. We've done T star and Z star, and some standard error of the statistic. Okay, when you're dealing with populations, we're dealing with proportions rather, we've done one sample. There's also two sample versions. We're going to get to this, I believe, next chapter. This is not in chapter 8. So this is one sample from one population. The mean of the sampling distribution is equal to population proportion. This is the standard deviation of the sampling distribution. This is what you use here, except you have to replace that with p hat because we don't know population proportion. That's what it is that we're trying to estimate. So this turns into that. I guess I should have pointed in a different order. Because we don't know population proportion, we have to substitute it with p hat, and that's what goes in there. Okay, as far as the means go, again, we do one sample and two sample overall. So far, we've only done one sample. I believe we start doing two sample stuff next chapter. The mean of the sampling distribution equals the population mean. This is the standard deviation of the sampling distribution. For the purposes of confidence intervals, other than those like special cases we've already talked about, we don't know population standard deviation. We have to use sample standard deviation, so this is what goes in that spot right there. For the Chapter 8 test, I am not sure at the recording of this video under what circumstances you'll be taking it. If you'll be taking it in class, I will make sure that you get a copy of this in order to use as reference. If this is something you'll be taking at home, I will make sure that this gets posted in Google Classroom so you can print it out or have that open as a separate window while you take the test.